Hi all. Some more problems from signal flow graph. Are the two systems equivalent? Here we have to find the transfer function Cs by Rs using the formula sum of Pk delta K by delta. So take the first signal flow graph. Here the forward path, only one forward path is there, that is A, B and C, and three loops AD, B and CF. So we can write the transfer function, that is transfer function is equal to forward path P1, that is ABC, and delta 1 is equal to 1 because all the loops are touching that particular forward path. Therefore for P1 delta 1 is equal to ABC divided by 1 minus sum of all individual loop gains, that is 1 minus AD plus BE plus CF. AD plus BE plus CF plus sum of gain products of all possible combination of two non-touching loops. Here these two loops are non-touching, these two loops again are non-touching, and this CF and AD are non-touching. Therefore, sum of gain products of all possible combination of two non-touching loops. That is, if you are taking these two loops, this pair, AD into B, that is gain product. AD is the loop gain, B is B is the loop gain of this loop. So gain product. So AD into B. For these two loops, gain product is B into CF, and for these two loops, the gain product is CF into AD. Then sum of gain product of all possible combination of two non-touching loops. So ADB plus BCF plus CF AD. Then minus sum of gain products of all possible combination of three non-touching loops. These three loops are non-touching, and its gain product AD into BE into CF. That is AD into BE into CF. So again minus sign. 1 minus sum of individual loop gains, then plus sum of gain products of all possible combination of two non-touching loops, then minus sum of gain products of all possible combination of three non-touching loops. So the transfer function for the first system is this. And if we are taking the second system, again forward path remains the same, A, B, C, and three loops AD, B, and CF. But here non-touching loops, one pair of non-touching loops, that is AD and CF. So the transfer function is forward path ABC, and delta 1 is equal to 1 because all the loops are touching that particular forward path. Therefore 1 minus sum of all individual loop gains, that is 1 minus AD plus BE plus CF plus sum of gain products of all possible combination of two non-touching loops, that is AD and CF, only one pair, AD into CF, AD into CF, gain product. So these two systems are different. Now find the overall transfer function of this system. Again here first we have to identify the forward path. So take forward path and loops for this particular system. So forward paths are G2, G4, G6, G3, G5, G7, then G2, G1, G7, then G3, G8, G6. Then two more paths are there, that is starting from G2, G1 minus H2, G8, G6, G6. That is one path. Another path is starting from G3, G3, G8, minus H1, G1, G7. So 6 paths are there. And again, what about the loop? G4 minus H1 one loop, G5 minus H2 another loop. One more loop is there, that is starting from G1 minus H2, G8 minus H2. This minus and this minus, it will get cancelled. Therefore, G1, H2, G8, H1. So 3 loops are there in this system, and one pair of non-touching. This minus G4 H1 and minus G5 H2. These two loops are non-touching, and its gain product is G4 H1 into G5 H2. So delta is equal to 1 plus 1 minus actually, but here 2 here minus sign. Therefore 1 plus G4 H1 plus G5 H2. Here it is plus, so minus G1 H2 G8 H1 plus sum of gain products of all possible combination of two non-touching loops, that is G4 H1 G5 H2, and delta 1 is equal to this forward path. So this loop is not touching in the first forward path, therefore 1 plus G5 H2. Similarly, delta 2 G3 G5 G7. This loop is not touching this particular forward path, G3 G5 G7. So 1 plus G4 H1, and for all other forward path, all loops are touching in all other forward path. Therefore, delta 3 to delta 6 is equal to 1. Therefore, transfer function is equal to 4. The transfer function is equal to, there are 6 forward paths. Therefore, P1 delta 1 say up to P6 delta 6 divided by delta. Then substitute all the values. That is the transfer function of this system. Now, determine the overall transfer function of the system whose signal flow graph is shown below. So here also first identify the forward path, that is G1, G2, G3, G4, G5. And the forward path is there, that is G6, G4, G5. Individual loop gains, that is, there are 3 loops. One is G2 minus H1, then G2, G3 minus H2, then G5 minus H3. 3 loops. These 2 loops are non-touching, and these 2 loops are non-touching. Gain product of 2 non-touching, G2 minus H1 and G5 minus H3. Its gain product is this much, G2, G5, H1, H3. Another second combination of 2 non-touching loops, that is G2, G3 minus H2 and G5 minus H3. So this will be the gain product of this pair. So delta is equal to 1 minus sum of all individual loop gains. So take the all loop gains, loop gains of 3 loops, then sum of gain products of all possible combination of 2 non-touching loops. So this plus 3, this plus this. So GP1 plus GP2. So delta is equal to this much, and delta 1 is equal to 1 because all the loops are touching in the first forward path. In the second forward path, one loop is not touching, that is G2 minus H1 in that particular forward path. This is the second forward path. This loop is not touching. G2 minus H1 is not touching this forward path. Therefore, delta 2 is equal to 1 minus G2 H1 or 1 plus G2 H1. Therefore, the transfer function is 2 forward path. Therefore, P1 delta 1 plus P2 delta 2 by delta. And substitute all the values. That will be the answer. Thank you.